Okay, we have the mineral groups. So I had mentioned a while ago, though, the different uh, properties of the minerals based on its physical properties. Now we are going to group or classify the minerals in terms of their chemical components. So approximately again, 4,000 minerals have been named and new ones are identified each year, but only a few dozen are common. So a while ago I mentioned that 8 elements make up the bulk of these minerals and represent more than or more minerals, among which are silicon, aluminum, okay, those 8 that I have mentioned, and silicon and oxygen comprises the first or the major portion, okay, being the silicates. So all silicate minerals have the silicon oxygen tetrahedron. Okay, but before we go to that one, so here we have the different mineral groups. So mineral properties are due to the internal arrangement of its atoms. So we know that for a certain minerals to have certain properties, so it can be attributed to its internal arrangement. So the most stable and least ambiguous basis for classification of minerals is based on its chemical compositions. Although we have physical properties, but to really identify minerals and group them or classify them, then we have to rely on its chemical composition. And this is more reliable compared to the physical attributes or physical properties. So here we have the different groups. We have the native elements. Okay, so we have the native elements, we have the silicates. So native, we have the silicates, we have the oxide groups, we have the sulfate, sulfide, carbonates, and halide. For native, okay, so we have gold, bismuth, and diamond. So we are going to discuss each of them. Okay, so silicates again, so they are mostly the rock-forming minerals, or most minerals that we have in the Earth's crust are made of or are grouped into silicates. Okay, so minerals containing two of the most abundant elements in the Earth's crust, namely silicon and oxygen, and they form this fundamental shape, or this shape we call the silicon oxygen tetrahedron. So we have in the middle we have the silicon, and then we have four elements or four oxygen, okay, forming a tetrahedron, meaning it has four faces. So one, two, three, and then four. So it has four faces. That's a silicon oxygen tetrahedron. And from this arrangement, you can have the different kinds or different types of silicates. So they can be arranged side by side, or actually you can research more on this one. But we will not dwell on this one. Okay, but let me let you appreciate it that silicates have this particular shape. Okay, so over 90% of the rock-forming minerals belong to this group. And aside from silicon, which is 46.6% by weight, and oxygen, 27.7%, the other most common elements that make Earth's crust are aluminum, iron, okay, the ones that I have mentioned in our previous topic. So this one, so oxygen being the highest, followed by silicon, and then all the other elements. So next group, examples of silicates, we have feldspar, olivine, pyroxene, mica, and quartz. So later we will dimensioning them in the different rocks. And actually, when we touch about magma formation, you will appreciate these um, minerals here. Okay, oxides. Examples of oxides, we have hematite, magnetite, limonite, corundum, and bauxite. So these are minerals composed of oxygen and iron combined with one or more metal ions. So if you're going to look at it, okay, it has oxygen. Okay, di ba? May karugtong siya sa anion part na oxygen. Okay. So next group, we have the sulfates. So minerals containing sulfur and oxygen in the form of SO4, negative 2, or in the anion. So the sulfates. So we have examples of them are gypsum, barite, alunite, selenite, gypsum, and halite. The ones in Mexico, the rock gypsum. Okay, this one. Okay, that one. Okay, that's a rock gypsum. Next, the sulfides. So minerals containing sulfur and iron. So S2 combined with one or more two ions. Some sulfides are sources of economically important metals such as copper, lead, and zinc. So we have examples of sulfides, chalcopyrite, galena, and pyrite. Next, carbonate. So minerals containing the carbonate or the CO3 and ion combined with other elements. If you're going to look at the chemical composition, we have CO3 here for calcite. So aragonite, witherite, okay, aragonite, calcite, malachite, azurite. Okay, so they have CO3 in the anion part. Okay, so uh, we know that calcite, one unique property of special property of calcite is if you drop an if you put drops of acid, it will fizzle or form bubbles. Or for calcite, it has double refraction. And then we have halides, so minerals containing halogen elements combined with one or more metals. So we have the halite and or the we have fluorite, so halogen elements. So the fluorite or that line in your particular group in your periodic table. So those are the halogens. So if they are mixed or combined with or they have minerals that are containing these halogen elements, so they form halides. So we have the native elements, minerals that form as individual elements like gold or lead, which are differentiated as or classified as metals or intermetals. So minerals with high thermal and electrical conductivity, typically with metallic luster, low hardness. For semi-metals, we have minerals that are more fragile than metals and have lower conductivity. Example are arsenic and bismuth. So we have arsenic, which is highly toxic, and bismuth. Okay, this colorful mineral here. And then we have nonmetals. They are non-conductive. Example are sulfur and diamonds. So we have diamonds here. We have the red, okay, or the precious diamond, and then we have uh, sulfur. These are examples of non-metals. They are non-conductive. So again, these are the different mineral groups. So under native element, we have gold, silver, copper, sulfur. For silicates, if you're going to look at it, they are composed or mostly composed of silicon and oxygen compound. So this one here. So muscovite, quartz, kaolinite, okay. And then oxides, okay, we have the oxygen, O4, O3, okay. the anions, oxygen. For halides, of course, we have fluorine, chlorine, okay. So for fluorite, for sylvite, and then carbonates, okay, we have CO3, and then phosphates, of course, it was not mentioned, but we also have this particular mineral group. So we have PO4, and then nitrates, NO3, sulfates, we have SO4, okay, and then sulfides, okay, we have the anion of sulfur, so sulfur anions. Okay, so those are the different mineral groups. Classification of mineral groups as classified based on the chemical compositions. So you can see here that we can differentiate them by their physical and their chemical properties. So I think that's the end of our discussion for minerals. Okay, I hope to see you again next in our next discussion. Thank you.